Viewers will be looking at heights and distances on mathematics. Height and distances on mathematics. It says this section deals with calculating the heights and distances of inaccessible objects. Full stop. The various methods to be adopted here will depend on the question. A good understanding of angles of elevation and depression and the concept of trigonometric ratios is very relevant. So under this topic, we should have a sound knowledge of angles of elevation and depression, and also we should also know how to utilize the trigonometric ratios in solving questions in height and distances. All right, now let's look at this problem. The problem says from 2 points A and B 43 meters apart and on the same horizontal line with the foot C of an electric pole. The angles of elevation of the top of the pole are 24 degrees and 37 degrees respectively. Find the height of the pole. So first it tells us about 2 points A and B which are 43 meters apart on the same horizontal line. You first draw a horizontal line. You draw a horizontal line, and then we are told that A and B are on the same horizontal line. So if this point is A, then here can be B, and the distance between A and B, is 43 meters. Okay, so this point is point B. It says A and B are 43 meters apart and on the same horizontal line with the foot C of an electric pole. Okay, so if we call this point C, that's an electric pole. Okay, so you are going to draw that pole. You extend it upwards. Extend the pole upwards. So I have this as my electric pole. Okay, I have that as my electric pole, and then it says that's the electric pole. It says the angles of elevation of the top of the pole are 24 degrees and 37 degrees respectively. So if this is the top of the pole, I can call the top of the pole T. So the angle of elevation of point A, of the top of the pole, from point A, this angle of elevation is 24 degrees. And the angle of elevation of the top of the pole from point B is 37 degrees. Okay, so we're having that. Angle of elevation of the top of the pole T from A is 24 degrees, and the angle of elevation of the top of the pole T from point B is 37 degrees. It says find the height of the pole. The height of that pole is small h. The height of the pole is small h, measured in meters. Okay, so that's the height of the pole, h measured in meters. Okay, this side becomes 90 degrees. And also you should know that the foot of this pole, the foot of the electric pole is point C, and the top of that pole is point T. Okay, so the distance between point A and B is 43 meters. Then you can also say that here, you can represent here as y. Okay, that's the distance from point B to C. Distance between B and C is y. Okay, that means that the total distance from A to C, distance from A to C is 43 plus y. Okay, so I'm having this as my diagram. Take notes. That's the diagram. That is the height of the pole h, and distance between A and C is 43 plus y. Distance between A and B is 43 meter. Distance between B and C is 1 meter. The angles of elevation at point A is 24 and at point B is 37 degrees. Okay. Right. If I cut out triangle BCT, if I cut out this triangle, say from triangle BCT, I'll have from triangle BCT, I'll have something like this. This is T, this is C, and this is B. Distance from B to C is Y, and here is H. Okay, this is 90 degrees. So the side that faces angle 90 is my hypotenuse side. Okay, then the side that faces this angle of inclination at point B, angle of inclination is 37 degrees, and the side facing 37 degrees, this side now becomes my opposite side. Okay, and then the remaining side becomes my adjacent. Okay, so the side that faces the angle of inclination is my opposite, and the side that faces the angle 90 degrees, this side that faces 90 degrees is my hypotenuse, which is the longest side of the right angle triangle. The remaining side becomes the adjacent side. Take note. So if we are to tackle this, given that the opposite side is H and the adjacent side is Y, you can say tan that is tan 37 degrees is the opposite side divided by the adjacent side, and the opposite side is distance TC, the adjacent side is distance BC, which is H divided by Y. Okay, so my opposite is TC, my adjacent is BC, that is H divided by Y. And if I cross multiply now, that means that H will be equals to Y tan 37 degrees, which I can call equation 1. That is H alone. Now you cross multiply this, you multiply this, and I'll have H as Y tan 37 degrees. Now we'll take the full triangle. You say from taking the full triangle from triangle ACT. If I take the full triangle from triangle ACT, taking the full triangle, the angle at point A is 24 degrees, and this is 90 degrees. This point is point T, and then here is C. Distance between A and C is 43 plus Y. It's 43 plus Y, and this is the height of the pole. Okay, and likewise the side facing 90 degrees is my hypotenuse side. Okay, the side that faces the angle of inclination is my opposite side. Then this remaining side becomes my adjacent. So I'm giving my opposite side as H and my adjacent side as 43 plus Y. That means that tan 24 degrees, see the tangent of this angle 24 degrees will be, so tan 24 degrees. Tan 24 degrees is the opposite divided by the adjacent, which is, so tan 24 degrees is the opposite of adjacent, and my opposite side is TC. My adjacent side is AC. So this now will be, this is TC over AC, and TC is equals to H. Distance AC is 43 plus Y. Okay, so distance AC is 43 plus Y, while distance TC is small h. If I cross multiply now, this multiply this, we have that small h will be equals to 43 plus Y multiplied by tan 24 degrees. Okay, so if I expand that now, this will multiply this, that is 43 tan 24 degrees plus this is Y tan 24 degrees, of which I can call this equation 2. This is H. Okay, now we equate both equation 1 and 2. I say equate 1 to 2. Equate equation 1 to equation 2. Equate 1 to 2. Like it's similar to saying equating h to h. That is equating h to h. At h here, h there is y tan 37 degrees, and h here is 43 tan 24 degrees plus y tan 24 degrees. Okay, so if I collect like terms, by collecting like terms, this one will cross over to this side, and I'll be having y tan 37 degrees minus y tan 24 degrees is equals to 43 tan 24 degrees. Okay, this is positive. Once it crosses the equality sign, it changes to what? Negative. That is minus y tan 24 degrees. So the common factor here is y. If I factorize it now, I have that y open bracket tan 37 degrees minus tan 24 degrees is equals to 43 tan 24 degrees. Okay, I'll then divide both sides by the coefficient of y. The coefficient of y is this, so I'll be having y tan 37 degrees minus tan 24 degrees divided by tan 37 degrees minus tan 24 degrees is equals to 43 tan 24 degrees divided by tan 37 minus tan 24. So you see that this will eliminate this. Now I have the value of y. I have my y as, we're having y as 43 tan 24 degrees over tan 37 degrees minus tan 24 degrees. Okay, and y will be equal to 43 times tan 24 with your calculator will give us, okay, so this gives us 0.4452. Okay, 0.4452 over this other one gives us 0.753. You can approximate 5 to 5, that is 6. 7536 with your calculator. 0.7536 to 4 decimal places minus 0.4452. Okay, so when I multiply 43 times 0.4452 will give me, okay, so 43 times 0.4452 give me this. When I subtract this other one, subtract the denominator, I'll be having 0.3084. When I subtract the denominator, I have 0.3084. Now when I divide, by dividing, I'll be having y as, when I divide, I'll be having y is equals to 62.07 meters. That's the value of y, 62.07 meters. Okay, now I've gotten y. I can then find h. I can use either equation 1 or 2. I say substitute y equals to 62.07 meters into equation 1. So if I substitute that into equation 1 then changes. Remember, this is equation 1. Equation 1 is y, h equals to y tan 37 degrees. So h is equals to y tan 37 degrees is equation 1. H now will be equals to 62.07 tan 37 degrees. And my h will be 62.07. Tan 37 gave us 0.7536. 0.7536. So if I multiply that now, 62.07 times 0.7536 will give me, this gives us h is equals to 46.78 meters to 2 decimal places. Okay, so this is the height of the pole. The height of that pole is 46.78. That's when I multiply this and this, I have 46.78. Okay, so take note, that is the height of the pole, 46.78. We got the value of y as 62.07. We have to substitute it substituting it in place of this y, I wrote 62.07, and then tan 37 is this 0.7536. When I multiply with 62.07, I have 46.78 meters. So take note of this diagram. Take note of the diagram. The height of the pole now. The height of the pole has been obtained. It has been obtained as 46.78 meters. 46.78 meters. All right.